Okie dokie. Okay, you got that? Let's have a look at this. Right. Let's see what words you know. I hope you know the or. Radius, good. And the theta? The angle, degrees, or radians, yeah. The S is called? Yeah, I would say the S is actually if you call it sector, that would mean the whole piece. But in my picture, I literally just want the outside of the sector. So, huh? That's too general. Too general. Do we know the word for it? Yes, that's it. Arc length. So, theta is the angle, or is the radius, and S is the arc length. Okay, I think you should write that down. My bike broke yesterday, but it cost so much to fix, it's not worth fixing because it's not worth much, the bike. But I left it at the train station, but I didn't put a lock on it. I'm kind of hoping someone will just take it. Then I don't have to figure out where to dump it. But I don't even know if it's worth stealing because it's so broken. Alright, you got that? Yeah? Yeah? Okay. Continue. So in physics, when we're dealing with motion in a circle, we don't actually use degrees. We use something called radians, yeah. Now, do you know what a radian is?
It's the segment of a circle.
Yeah. Yeah, and what's the precise relationship? So it's something to do with the sector of a circle.
How many?
You probably would have used radians before.
Yeah.
Huh? Yeah, not this year yet. So look, roughly speaking, you can say it's about 57.3 degrees. And the reason will be explained more in maths class. And the 57.3 is actually 180 over pi to be precise. And it's important in physics because we use radians to measure angles. Now, Zach was talking about, and I think maybe Dorian, you were trying to get to it as well, precisely what a radian means. So when you have a circle of radius r, and here's another radius of r, if this arc length is also r, then what you have here is exactly what's called 1 radian. Now, maybe I'll change the definition a little bit. Yeah, let's do, no, sorry, getting very excited. Let's do some live changing of the notes here. I'll make the definition a little bit nicer. Right. In physics, when we're dealing with motion of a circle, we do not use degrees. The radian is defined as follows. It is the angle which gives an arc length of r in a circle of radius r. mathematically. Okay, that's a bit better. I think it would be good if you add this picture to your notes. Visually, a radian is a sector where you have or. Is that what you were thinking of? Yeah. Compiling. Come on. Great. This baby here has 2 gigs of RAM. 2, not 1, 2. It originally, when I got it 5-6 years ago, I had 1 gig, but then I upgraded it to 2 gigs. So you know, now it's like. So now it's now it's like a gaming machine. You know. Right. So circular motion. Let's get the definition again. Radians, I mean. So, in the exam, they've asked this one recently, and they like the definition reference in the arc length. It's the angle which gives an arc length of r in a circle of radius r. So, roughly, that's 57.3 degrees. Okay, can you write that much down? Got that? Yep. Can you see, Regina? Okay, continue. Yeah. So. Here's some little simple ones for us to practice, and I'd like you to use your calculator to tell me 0.25 radians in degrees and then 30 degrees into radians. I want the answer in the usual 3 significant figures. In the exam, sometimes they use this and sometimes they use this. It depends on who writes it. I feel like the new person is more likely to use, let me get into his mind, this one. Yeah? Well, I'll show you actually on my calculator if I open it. Okay, so 0.25 radians into degrees is multiplied by 180 over pi. That's one way to do it. Okay. 14.3. Did you get that? The next one, the other way around, 30 degrees into radians. That is 0.524 radians. Okay? Are we okay with that? Yep. We've seen two types of motion so far in this course. The SUVAT motion in one dimension and in two dimensions. So, you know, the projectiles and the linear motion. What we're going to look at now is a new type of motion called motion in a circle. Firstly, what makes something move in a circle? So I'm sure some of you maybe know this, but if something is moving in a circle, what do we know about the force that is making it do this? But for example, if something is moving in a straight line, it has an acceleration, then there must be a force like that, right? If something is moving in the air, then we know that there must be a force like that. Okay, my question is, and I think some of you might know this, if it's moving in a circle, what do we know about the force? Sorry, I'm not sure if you're saying anything or mumbling. Go on. Good. What about it? What is that? Perpendicular to the radius. Is what? What is perpendicular to the radius? No. You're thinking of the velocity is perpendicular to the radius. Look at how hard she's thinking. Can you remember? No. If an object is undergoing circular motion, then there's a net force acting on the object which is perpendicular to the velocity and is directed towards the centre of the circle. So as a picture, if something is moving in a circle, then what you have is a velocity this way. Here's the radius, and the force is perpendicular to the velocity, like that, and it's also pointing towards the centre of the circle. Okay, so if I draw it here, I know the velocity is this way, and then the force is that way. Yeah? This is the definition of circular motion, which they sometimes ask in the exam. So we need to write this down carefully. What's absolutely important here, the most important thing, is that the force is towards the centre of the circle. It's the most important thing. Got this? Yeah? Yeah? Not yet. Yeah? Are you sure? Okay. I already drew it. You mentioned this word earlier, Dorian, centripetal. So centripetal force is the type of force that acts on any body that revolves around a circle. This force contributes to keeping the body in circular motion. So in other words, this force here, we can call this the centripetal force. This is the name we give to the force that makes it move in a circle. For example, like here, what do we call this force? This force is called the weight. Right? Do you remember what we call this force? Very good, the thrust. And this is called the weight. This force is called the centripetal force. Now, what I think would be good to do is if you draw this picture and you can write the name down, the centripetal force. You got that picture, Dorian? Yeah. Continue? Yeah. Okay. Yeah? Okay. And we know that F equals ma. For example, if m is 1 kilogram, then basically F is A. The following should not surprise you. Which direction is the acceleration in this picture? The acceleration is also here. Because remember, F equals ma. And both of these are vectors. So wherever the F points, the A points too. Another example, this is the weight. Which direction is the acceleration? The same. Okay? So A is in the same direction as F. That's not news. And what do you think we call this A? What is this called? Go on. Yeah, go on. What is it? Yeah. Isn't physics great? The centripetal acceleration. So if you can add that to the picture.
Wouldn't that be a resultant force in the diagram?
No, sometimes students think this now, but amazingly no, the force is strictly towards the centre.
So what is V then?
This is the velocity, the speed.
So can't you resolve the two to get a diagonal force?
Yeah, but they don't add together. Because one is,
Oh yeah.
yeah. Okay, you got that? Yeah?
So there would be two accelerations.
No, it's strange. The acceleration is perpendicular to the velocity. So this velocity is changing, and you would think the acceleration perhaps should be in the same. That's what you're thinking, isn't it? It should be along there, but it's not. Amazingly, it's perpendicular. It's strange. It's strange, yeah. That's what we just said. Okay. Oops. Now, our first term, well, not our first because we did arc length, angular velocity, omega. This is the rate of change of angle with respect to time. And the units are radians per second. So, I'll give you an example just before you write that down. Let's say you have something moving in a circle. It starts here. And then it takes 1 second to move 1 radian, and then another second later it's moved 2 radians. Okay, how quickly does the angle change? It's changing at a rate of 1 radian per second, or in other words 1 rad per second. We call this the omega, the angular velocity, how quickly the angle changes. Is this something you've seen before or not? No? Maybe you used this symbol, theta dot.
No, I never learned this before.
But how the heck did you know the word centripetal?
Ready.
Oh, okay. In circular motion?
What's centrifugal force? The opposite. It's in the opposite direction.
Yes, it's a reaction force.
Like in the centrifuge.
In a centrifuge, exactly, yes, yeah. It's the reaction force between the mass and the test tube. So it creates the feeling of it being pushed out. So yeah, it's opposite direction of the centripetal force. Yeah. Centrifuge. What's it called? The machine? Centrifuge, yeah. Yeah.
They used to
Separate, yeah.
things in the
Oh yeah. Yeah. Don't know, do you use that in chemistry?
Sometimes, I mean.
Yeah.
Yeah, in chemistry they use it
Yeah.
to separate the different.
It's used in physics when they're doing the refining of the radioactive material. Like when they want to refine it to separate out the uranium or whatever, they do it. But I can't remember how the process works, but you need to have like a really precise omega. Like it has to be like bang on perfect so that you can get the out. Yeah.
That's what Stuxnet was.
Yes, it was the virus the Israelis wrote for North for Iran.
Yeah.
Yes.
It changed the omega, yeah.
It changed the omega, correct? Yes, that was a very significant virus. That was in the 90s, I think. I don't know if the Israelis or the Americans ever admitted to it. It was, yeah, but I don't know if they ever admitted to that virus. But everyone kind of knows it was them. Yeah. All right. Next now. Periodic time T. Does anybody know what this means? Think about the circle. What could it mean? Think about the word periodic. What do you think? Do you think you know, Harry? No? What do you think it is? Yeah, it's the time to move around once. The periodic time is the time taken for one orbit to be completed. Of course, the units are seconds. Okay. Okay, you got that? Yeah. So, for example, if t is 2 seconds, then it takes 2 seconds for one orbit to be completed. Pretty straightforward, right? Now, the unit per second has a special name. So, we've seen in physics, sometimes when you have units, you can give them new names. Like, for example, Newton meter is also called joule, very good. Newton per kilogram squared is also called what? the heck, Stephen? I just made up a new unit, sorry. Newton per meter squared is also called. Not this one. Yeah, come on, what's it called? You know it. Pascal? Oh, yeah. And kilogram per meter cubed. That it doesn't have a name. Do we do any others? No, that was it. Wasn't it Pascal and Joule were the two special ones, weren't they? Did we do any other special one? Yeah, but there was no special unit for that. Was there any other ones that were special? Oh yeah, so like for example, kilogram meter per second squared. Newton. Yeah? Yeah, okay. Right. So anyways, the unit per second has its own name. Does anyone know the name of this special unit per second? Think about it. Correct. The unit per second is often called the Hertz. That is 1 Hertz equals 1 per second. Yeah, you should write that down.
I'm guessing Hertz was a famous scientist.
Yes. Physicist. Where was he living? Is he German? No, French.
Austrian.
He was working at the same time. An Irish physicist was working on the same topic called Fitzgerald, but Hertz kind of published before Fitzgerald. But I remember my physics teacher telling me that if Fitzgerald published his work before Hertz, then this would have been called the Fitz instead of the Hertz, named after Fitzgerald. Yeah, so it was a little bit too slow. So it's the Hertz and not the Fitz. Okay, you got that? Yeah. The frequency F. Does anybody know this definition or this term? Frequency. I mean, you should know this word from English, I think. Frequency. What does that mean?
That's the time it takes for something to just reoccur.
No, that's the periodic time. It's 1 over the time. But what does it mean?
For example, like in a wave,
Yeah.
the time it takes to go down and up and down. Like,
Yeah, but it's not time. It's
no,
not time.
like how many?
How many? That's it. Yeah. So it's how many in a second. Okay. So a frequency F is the number of oscillations in 1 second, or orbits in 1 second, and the units are the per second, the Hertz. So if F equals 2 Hertz, then that means there are 2 orbits in 1 second. What if F is 0.5? How many orbits in 1 second? Only half an orbit. Yeah? You got the idea? No? So, you look a little confused. If I say F equals 2 Hertz, then that means in 1 second it does this. 1, 2 in 1 second.
Or you can think of
Yeah.
it and want it to refresh it.
Yeah, what's that? That's like 50 Hertz. So there's 50 cycles of the image in a second. 60 or 50. What the heck is this one? Oh, this could, I don't know, this could be even 100. And the fancy one's 100. The high-end ones.
I mean, ASUS just made a 300, the first 300 Hertz.
Yeah, but I mean, what's the point? Because you can't ever go to see 300 difference.
Oh, it's mainly
Like, how
for
quickly can-
professional game esports and I mean, I used
Yeah.
to, I used to got it when we were 240 Hertz. But it's huge different with 60 if you compare.
If you can feel a difference,
Yes, of course,
really?
When you're moving the mouse, it's more fluence.
You can see a difference between 60 and
Yeah,
240.
when you're
Over the
between
website.
60 and 144 and 240 is a big jump.
Yeah, maybe. I'll believe you. It just, to me, I would have thought 60 is enough. But-
when you're like doing some FPS games,
Yeah, okay.
there it was loose.
Okay.
It's the same as all those movies that they made
Ah,
recently that it's high quality that you don't really difference the, from one, all the frames per second and all that. It's just,
Yeah, still, I think 60 is enough.
YouTube got like, or when a 1080, 60.
Yeah.
Yeah, it's more fluent one compared with the 65.
Yeah, no, I can accept that there's a difference between 30 and 60.
Oh, okay.
But I have trouble accepting, and I could accept there's a difference between 60 and 100. But I have trouble believing that you can really see a difference between 100 and 200. I just think. And maybe it's my eyes. Maybe.
Yeah, my
Maybe
room
I
got
can't.
144.
Yeah.
Then to my 240, I can't really tell.
Yeah. It's going to be harder to tell the difference after that. I mean, you're still a human. You're not a machine. So, all right, you got that written down? Yeah? Okay. So, I think, that might be a good point to stop, because then the next thing we're going to have a look at is all the formulas, So, I think, that's all the definitions taken care of. And then we still have to look at examples. So, there's still a bit more to do in this. But we'll leave it there. That's plenty. For today, time for lunch. What's for lunch today?
Leftover pizza.
Yeah, nothing wrong with leftover pizza, that's for sure. Especially if it was a good pizza.
Yeah.
What was it?
3 cheese and salami and